We're here in an entirely empty new Unity project. The finished project after all 3 parts will be available on my Patreon, link down below in the description to go get that, if you want to follow along with that. If not, let's just get into the tutorial. We're going to add a couple of simple things to begin with, like adding a plane so that we can have a floor. And we're going to be adding a cube for our player character for the time being. Obviously, in your own game, this will just be your player character. For now, let's put the camera somewhere usable so that we can see the entire playing field. And we'll rotate it down a little bit so that we can see what we're doing. Alright, now, in our player, we're going to be adding a rigid body, meaning that it's going to have physics. And then we're also going to be adding a new script, which we're going to call player movement. In that player movement script, we're going to first get a rigid body variable. We'll call that RB. And in void start, we're going to give that a value of get component rigid body. Now we have a direct reference to the rigid body on this object. And before we get moving on to the actual movement, we're going to make a serialized field up here. It's going to be a float, and we'll call that move speed, something of the like. And we'll set it equal to like 10. We'll be able to change this value in the actual Unity editor in a moment. Then down here in the update function, let's zoom in a little bit so that you can actually read what I'm doing. In the update function, we'll make another float, and we'll call that something like horizontal input. That'll be equal to input, get axis raw, horizontal, multiplied by our movement speed variable from before. Then we can just copy and paste this line over, because we're going to also obviously make one for our vertical input, which will use the axis for vertical. Now, our rigid body velocity will be equal to a new vector 3, and it autofills here to horizontal input, vertical input 0. That is not correct, because as you can see, this is the x value, this is the y value, this is the z value. But to move along the ground, we'll be needing to move along the x and the z. The y value is actually the up and down value. So we'll be taking the vertical input and putting it into the z slot, and the y value will be 0. And now we can see that we can move around, but we're kind of like tumbling around, and if this is what you're looking for, fantastic. This works, but it's probably not what you're looking for. So what we can do is over here in the rigid body, we can go into our constraints, and we can freeze the rotation along all of the axes. If you want to rotate this object, you've got to rotate through the transform. The rigid body rotation is separate from that. So you don't want to rotate this thing at all. We only want to be able to move it into different positions. So once we've done that, you'll be able to see now our cube is just messing about. It's a little difficult to see. Let's put a different material on this real quick and just make that material some darker color so that we can actually see what we're doing. And as you can see, we are now moving, being able to jump. So after all that, we'll just add a if statement here, and that is if get button down, and then we'll need to give it a name for a button, which will be jump, something that Unity Engine provides for you. If that is the case, we'll set rigid body velocity equal to a new vector 3 again. We'll keep the x and z values the same, which we can do by just putting in rigid body velocity.x and rigid body velocity.z. We'll also need a new serialized field for our jump speed or jump height or whatever you want to call it. Let's put that to 5 for the time being. And that will be our y value, so we can just put in jump. And if you want to see what keys that refers to, you can always come up here into edit, project settings, put it somewhere in your workspace, and in input manager you've got all of your axes here. So jump corresponds to the space. There's a bit of an issue though, and that is because we just kept the value for the jumping at 0 in our movement for left and right and up and down, we can't actually jump, because the moment we start to jump, the next frame our jumping gets reset back to 0 because of this little line of code. So what you'll do instead is you'll keep this at rigid body velocity y. If you're putting a new value in your velocity, if you don't want anything to change, you are very tempted to put in a 0, and that's exactly the reason that we did that, to show you why you shouldn't do that. This is the way to say to the rigid body, you know what, this axis, just keep going. Don't put in a 0. Now that we've done that, you can see we can jump, but we can jump infinitely, which is less than ideal. Luckily, there's a quick little fix for that, and that is in this if statement. After we check for get button down, we'll also check with a 2 % signs for a math function called approximately, and you will be able to see if you hover over it, we need a float A and a float B. So we're going to be comparing our rigid body velocity y, which is our up and down movement, to a value of roughly 0. The reason we're not checking for it to be exactly 0 is because of the way rigid bodies work. They're never exactly standing still, technically speaking anyway. But if you're putting something like that in code, it is going to look exactly for 0, and that's just never going to happen. This is a good approximation though. So now we won't be able to jump if we're either already moving up or if we're still moving down. And now, as much as we spam, I don't know if you can hear me spamming the spacebar, we'll only jump when we're on the ground. And that's basically our character controller. Now, one last thing is the character isn't facing in the direction it's moving, which is kind of not great, right? And you might think that is going to be an absolute pain to fix, because how in the world are we going to do something like that? Well, I'm here to tell you, relatively easily. Because we've got a simple function for that in Unity, and we can use transform.forward, which is the forward direction for your character. And you can actually set that to a new vector 3, which will be equal to the rigid body velocity x and rigid body velocity z, and the middle one here we will actually put in a 0 because we never wanted to be looking upward. If you do, obviously you can put rigid body velocity y in there. This will give you the movement direction of the character, and then just set the transform forward to that movement direction. So as you can see, that works like a charm, and now we're moving around. And if you're using a controller, because you totally can, you have 360 degrees of free movement. And just as easily as these couple of lines of code, we're still under 30 lines of code, we have a functioning 3D character controller. Now, as a little bonus, we're going to give you a little script here for the camera to move with the character, because now we're very much looking down on the character, which isn't very fun. So let's move it a little bit closer. That's about right. Maybe that's a little too close. So what we can do is we can add a new empty object, which will be a parent to our camera. So we'll put the camera under this empty object, and we'll just add a script to this empty object now. And we'll call that follow player. In here, we'll add a new serialized field, a transform for the player, and we simply just put our own transform position to be equal to the player position. Then in here we grab our player, which in our case is the cube, and put it into the open slot here. And now this empty object will always be on top of the player, which will then result in when the player moves, that object will move with it, and since the camera is parented to it, the camera will move proportionally as well. So as you can see, now that we're playing the game, it's kind of hard to tell that we're moving around, but the camera is moving with us and I just walked off the ground. Clearly we need a little bit more space. But that is one of the big upsides of doing it this way, because we can just adjust the camera in our 3D viewport here. Just say move it a little bit more back, maybe a little bit more up as well. And our follow player script still works like a charm. We already made a follow player script. Let's start off with adding a couple more serialized fields here. One is going to be a float for the mouse speed, which is the speed at which the camera can move. We'll by default set that to 3. That's the setting that I use in my game. And another serialized field as well, another float, which will be the orbit dampening. Or damping, I can't type, that's fine. Which we'll set to, in this case, 10. We're going to be using these two variables in the math to come. It's not as complicated as it sounds though, so don't worry. And we'll also add a vector 3 that we'll call local rotation. We're going to change the local rotation.x to be plus equals, not just equals, we're going to add to whatever value it is right now, by inputs.getAxis, and the axis that we'll be using is called mouse x, multiplied by our mouse speed. So every frame, this will look at how much our mouse has moved since the last frame in the x-axis, and add to our local rotation x based on that. And of course we're going to do the same for the local rotation y and use the mouse y axis. This is entirely up to you, but for the up and down, also for the left and right if you want to, you can invert the controls if you just use minus equals instead. I personally think a plus equals for x and minus equals for y feels the best. But depending on what type of game you're making, depending on what kind of thing you want your players to experience, your mileage, of course, may vary. Now, your Y rotation, which is the rotation up and down, can now go through the floor and also over top of your character, which is not ideal, because when it goes through the floor, you're going to be clipping through the floor. That's going to look unpolished because it is unpolished. And if you allow the camera to go over top of your character, the entire view will start being upside down, which is also not what we want. So we're going to clamp this. We're going to say our local rotation.y is equals to a math function called clamp, where we'll add in 3 values. First, the value that we're clamping, which is local rotation y. Then the minimum value, which is going to be a 0f, which just means 0 degrees, f because it's a float. And then you can go up to 90. I prefer clamping it a little before 90 degrees, so I like using 80 degrees for this. Now your Y rotation will always be between the values of 0 and 80. It can't go below 0, so it can't go through the floor. It can't go over 80, so it can't be exactly like looking down at your character or even flip over. After that, we're going to add a quaternion. Call it whatever you want. QT is short, I find. And the autofill in this case entirely correct. We're going to be using quaternion.euler, local rotation x, local rotation y, and 0. Real quick, you do want to watch out because I did say the autofill here was correct. It's actually not. We want to change the y and the x around. So our x value is going to be our local rotation y. Our y value is going to be our local rotation x. That's mostly because, number 1, quaternions are weird. Number 2, Unity's direction is also weird. This will turn our vector 3 and our separate axes into a quaternion, which is used for rotation in Unity because it's long and technical, and I'm not going to pretend like I understand quaternions fully, but basically it's a better way to rotate 3D objects. Right now though, we have yet to actually rotate this object around because we've made a quaternion variable, but we're not using it yet. So we're going to set our transform rotation. We can just set it equal to QT and that'll be fine. But in order for this to be a little bit smoother, what you can do is you can go quaternion.lerp and we'll get our current transform rotation. We'll lerp to our QT quaternion in a time of time.delta time multiplied by our orbit damping variable. These are your lines of code. Everything there is to having an orbiting camera. So now when we go back into the game, we'll be able to see that we can in fact orbit around our object, but it's a little weird, right? And that's because we want the camera object to be not rotated, which at the moment it's not. That's great. So first and foremost, let's position this camera to be a little bit better. Rule of thumb is your position needs to be at 0, and then your Y position doesn't matter, that's the height, and then the Z position is the distance from the player. Now, our empty game object spawned in a really weird location, so if we just push that around a little bit, better yet, just copy the position and paste it onto our empty game object. will be exactly orbiting around our cube, and we can't go over this far and we can't go below this far. Only issue being is if we rotate it around a little bit, you can see that our movement is very much independent of where the camera is, and that is very confusing. You're going to want your movement to be depending on where the camera is. Let's open up the player movement scripts that we've made. This is the player movement. It's very easy and very simple. We're going to be changing some things around. We're going to be adding to it in order for this to work the way we want it. First and foremost, on top, we're going to add a new serialized field, which is going to be a transform for our camera. Then after we get these inputs, we'll also make a vector 3 for the camera forward direction, which will be equal to cam.transform.forward. In theory, we can get the transform out of there because this is already a transform. And then vector 3 again, which will be the camera right direction, which will be equal to cam.right. This way we at all times know what the forward direction and the direction to the right of our camera is, meaning that we always have an idea as to where it's pointing and how it's pointing there. That being said, we're going to want to influence this immediately because our cam forward.y needs to be equal to 0, because as we discussed in the last two videos, the y rotation will be the up and down rotation, and we don't want that to impact. We only want the horizontal rotation of our camera to impact what we're doing. So the same will go for camera right.y, also will be set to 0. And I'll actually make some comments here. So we'll call this inputs, we'll call this camera direction, and then we'll make a thing where we create the relative camera direction. So we'll create a vector 3 here, and we'll call that forward relative. And this is going to be our relative forward movement. So that's going to be our vertical input multiplied by our camera forward direction. This will do two things. Our vertical input is going to go from being just simply a float to being a vector 3, but it's going to be a vector 3 that is influenced by where the camera is at that frame. And you can probably see what's going to happen next. That is going to be a vector 3 as well for the right relative, and that's obviously then going to be our horizontal inputs multiplied by our camera right vector 3, and this does the exact same thing. Again, it gets our horizontal inputs and puts it into this vector 3 based on the right vector of the camera. And then if we simply add these two together in a vector 3, which we'll just call movement direction or something simple like that, and we just simply take our forward relative, and to that we add our right relative, we have a vector 3 that we can use for the movement direction. So let's start programming the movement itself. Because as you might imagine, we can just use our movement direction X and our movement direction Z in place of here, so that we still have the rigid body doing all the movement. And now if we go into our player movement, and we can see we need to put in the camera, which is important that we don't use the parent object, we use the actual camera object into this transform slot. If we move forward, we'll be moving forward, but if we then turn the camera around and we move forward, we are now moving forward depending on where the camera is looking. So if we change the camera, you can see that changes our movement direction. And the same thing with moving right. If we move the camera, it's hard to see with the cube being what we're using here, but this is changing our movement direction relative to our camera. And with that, we have more or less our full character controller for a 3D game, whether it be an action RPG, a shooter game, a 3D platformer, whatever you want to make. This is going to be the basics of mostly any 3D character controller you want to make. So if you want to play around with this entire project, there will be a link down below in the description for you to download it on my Patreon. And you can play around with the code if your version of it is not working, or you just want to steal my code, that also works. And for more tutorials much like this one, I would very much like you to ask to subscribe to the channel and give this video a little like to encourage me to make more like this.